This is a sample application utilizing rational expressions. To train for the running of a triathlon, Jerry jogs 1 hour each day over the same 6-mile course. 4 miles of the course is downhill, whereas the other 2 miles is on level ground. Jerry figures that she runs 4 miles per hour faster downhill than she runs on level ground. Find the rate at which Jerry runs on level ground. So we can see that what we are looking for is her speed that she runs on flat ground. So again, this is talking about distance and speed and time. So we're going to utilize our distance equals rate times time formula. Now what I see on here is that they're talking about she's jogging a whole hour, and it takes her the whole hour to do the course. So I'm still going to go ahead and rewrite the equation in terms of our time, which is distance divided by rate. But in this case, I'm going to be adding my time together. So I'm going to have time plus time equals 1 hour. So let's go ahead and take a look at what we need. We need distance over rate plus distance over rate is going to equal 1. So she's got a 6-mile course, and part of it is downhill. 4 miles is downhill, which leaves only 2 miles to be on level ground. Now in this particular case, there's nothing affecting her, like an outside current or anything like that. It's just her speed. So we're going to make the x be the speed that she runs on level ground. And she ran for 2 miles on level ground. So for the other 4 miles, she went downhill. And she runs faster going downhill by 4 miles per hour. So we're going to add 4 miles to her x. And this is all equal to 1. So that is the setup for this type of application. Now from here, we need to simplify and solve. We're going to use our least common denominator method. I can't do proportions because I don't have a single fraction equal to a single fraction. So my LCD for this problem is made up of the x and the expression x plus 4. So I will be multiplying each term by that LCD, reducing whatever denominator I can. That includes doing it on the right side of the equal sign. So in my first one, my single x's will reduce, and I will get 2x plus 8. So I'm multiplying the 2 through x plus 4. In the second one, the x plus 4 expressions will reduce, and I'm left with 4x. Now on the right side, there is no denominator to reduce, so I'm just going to distribute my x and get x squared plus 4x. So now we need to simplify, put all of our like terms together, and solve this expression. So on the left side, I see that I have 6x plus 8, and the other side I have x squared plus 4x. I'll move everything to the right side because I want my x squared to be positive, so you're subtracting 6x and 8 and moving it to the right side. So here we have our equation. X squared minus 2x minus 8 is equal to 0. So to solve this, we will factor. We will have x minus 4 and x plus 2 is equal to 0. Our two choices for answers are 4 and negative 2. But this is an application. So a negative 2 speed doesn't make any sense. So in our case, since we made x be the speed she runs on level ground, her answer, or her speed, is 4 miles per hour on level ground.